Okay, problem 19. They're asking for delta H. I'm looking for my keywords. My keywords are going to be bonds, F, or steps. All right, do not see bonds, do not see steps. Looking for formation values. There it is. Delta H, if I see formation values, is going to be equal to the sum of the products minus the sum of the reactants. Watch out, because products is usually right minus left. It always is. Bonds broken minus bonds formed is left minus right, because the reactants break to form the products. Be aware of that. So my product is C6H6, 83 kilojoules per mole. My reactant is C2H2. There are 3 of them, 3 times 230, and this is going to be equal to an exothermic reaction of negative 607 kilojoules per mole. I'm not sure why they didn't put moles in the unit here, but anyway, the answer is A. Distractor would have been B if you forgot that. So, okay, a lot of people missed this problem. A lot of people picked D. Apologize, the answer is A to this. You got to watch really closely, okay? According to the information above, what is the standard reduction potential for the half reaction here? Okay, so it all is based on E cell, or E total, equals negative E ox plus E reduced. They gave us E total. 2.46 equals negative E ox plus. Now notice, in this problem, silver is reduced, and they gave us silver being reduced. So the one who is reduced is the silver, and the one who's being oxidized is this M. So the silver value is 0.80. Okay, so watch this. Here we go. So now we know that in this problem, M, okay, is being oxidized to M3 plus. So when we solve for that, we get 1.66 is equal to negative E ox. So negative E ox is 1.66. And that means that the opposite of that is 1.66. So we move this around, we get E ox is equal to negative 1.66 volts. Now, everything listed in the chart is based on the reduction. Okay? Notice here they're asking for E ox, or they're asking for the reduction of it. So the reduction of it is going to be the opposite, which is negative 1.66. Am I saying the correct thing? Yes. Yes. So the value is negative 1.66. Another way of looking at it is you could have just done 2.46 is equal to E ox plus E reduced. Then you get 1.66 is equal to E ox. There it is. But they're actually asking you for E reduced. This is reduced. So you plop the negative on there, negative 1.66. So be aware, when you guys solve for 1.66 volts is equal to M going to M3 plus, because it is the oxidized portion of this. They're asking you for M3 plus goes to M, which is going to be the opposite, negative 1.66. Okay, 21. 87.5% of a sample of pure iodine decays in 24 days. What is the half-life? Okay, you could have done this many different ways. You could have kept taking half of 131, which is its molar mass, until you got down to 87.5% of its having decayed, and worked backwards from there. Or since they're dealing with percent, you could have just started with 100%. And after one half-life, 50% was going to decay. And after one half-life, 25% decayed. And after another half-life, 12.5% would be left. So 12.5% is what's left, but when 12.5% has decayed, is left 87.5% has decayed. So 1, 2, 3 half-lives have taken place. Okay, that divided by the total time gives us 8 days per half-life, making the answer B. Which of the following species does not have a tetrahedral structure? Well, A, immediately CH4 is a tetrahedron. Let's do B out. NH4, boom, 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 boom. We're going to lose an electron from the middle because it's positive 1. Plus 1, 4 things, no lone pairs, that's definitely a tetrahedral. Let's do C, F, 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 F. Remember, each F has 1 space to bond. So I'm just going to draw 1 dot on the F's. S has 2 spaces to bond. We've dead-ended. We cannot shift, so we have to split. We can't shift because we will lose the F's. 4 things, 1 lone pair. That's going to push it into a seesaw shape, not a tetrahedron. C is going to be the answer. You can go back and look at D and E. E and A are exact same thing. You're just going to have halogens on the outside instead of the hydrogens. 23. A gas sample is confined to a 5-liter container. So constant volume of 5 liters. Which of the following will occur if the temperature of the container is decreased? We're talking about a gas and we're talking about temperature. Kinetic energy is directly proportional to the temperature only. So if T goes down, kinetic energy goes down. Okay? So we know that for sure. 1, the kinetic energy of the gas will decrease. Very, very true. Look at the way I'm making my predictions before I go through and answer it. So 1 has to be true, so we can get rid of B as a choice. The pressure of the gas will increase. All right, let's think about our PTV stick. We know that volume is constant. So if T goes down, the whole thing is going to look like this. And P would also go down. So pressure will decrease, not increase. So we can get rid of 2 as an option. So it's between 1 and 3. The density will increase. Okay, density equals mass over volume. We know that volume in this case is constant. Let's look for any sign of pumping more gas in or increasing the mass. It's confined. Which of the following will occur if the temperature is decreased? We're not changing M at all. So the only viable answer is A, kinetic energy and temperature relationships. Consider the equilibrium above. Which of the following changes will increase the concentration of SO3? So essentially they're asking which one will make it shift right. Okay, decreasing the concentration of O2. Decrease, it's going to shift towards, so that makes it shift left. Increasing the volume, it's going to shift to more moles, and there are 2 on the left and 1 on the right, so that's also going to make it shift left. Adding a catalyst is just going to speed it up by decreasing the energy of activation, so it can't be that. Increasing the concentration of SO2, up, and away, and that's going to shift it to the right for sure. Increasing the temperature, well, it's exothermic, so temperature is released. If temperature increases, it's going to shift away, so that's going to make it shift to the left. The answer is D in this case. Last problem, 25. What mass of AU is produced when 0.05 moles of AU2O3 is reduced completely with excess H2? So let's write out the reaction. AU2O3 plus H2. We know that we're producing AU. And hydrogen and oxygen are going to make H2O. We're going to balance this by putting a 2 here. We're going to have to put a 3 here and a 3 here. We have 0.050 moles of AO2O3 and we want grams of this. Well, we have moles, so we can use the mole ratio of 1 to 2 to get to AU and use the molar mass. 1 mole of AU is equal to 100 and I believe 97 grams. So after you do out this math, you're going to get 0.1 times 197, which is going to be 19.7 grams of AU. I apologize, I'm speeding here. I got a couple seconds before YouTube shuts me down. Okay, take care, guys. Call me if you have any questions.